Welcome to Fundamentals of Cybersecurity, CSCI150N. This is Chapter 21, Change Management, and I'm your instructor, Peter Keurig. In this chapter, you will learn how to use change management as an important enterprise management tool, institute the key concepts of separation of duties, identify the essential elements of change management, implement change management, and use the concepts of the capability maturity model integration. The outline for this lecture will include why change management, the key concept of separation of duties, elements of change management, implementing change management, purpose of a change control board, and capability maturity model integration. Change management adds structure and control to the development and management of large software systems as they move from development to implementation and during operation. Change management is often applied to the management of changes in business environment, typically as a result of business process reengineering or quality enhancement efforts. Configuration management is considered synonymous with change management and, in a more limited manner, version control or release control. Configuration management is the application of change management principles to configuration of both software and hardware. Change management provides discipline and structure to help conserve resources and enhance effectiveness. Change management is often considered expensive, non-productive, unnecessary, and confusing, an impediment to progress. However, change management can be scaled to control and manage the development and maintenance of systems effectively. Change management should be used in all phases of a system's life, and to include development, testing, quality assurance, and production. Short development cycles have not changed the need for any appropriate amount of management controls over software development, maintenance, and operation. In fact, short turnaround times make change management more necessary because once a system goes active in today's service-based environment, it often cannot be taken offline to correct errors. It must stay up and online or business will be lost and brand recognition damaged. For example, if Amazon had to take down its entire service to fix a problem with their back-end database. In today's volatile stock market, for example, even small indicators of lagging performance can have dramatic impacts on companies' stock value. So once again, imagine if Amazon lost an entire day of sales to fix a single database problem. So the scope of change management. See if you can explain why each of the following should be placed under an appropriate change management process. Web pages, service packs, security patches, third-party software releases, test data and test scripts, parameter files, scripts, stored procedures or job control language type programs, customized vendor code, source code of any kind, and applications. Well, each one of these should be under a change management process because web pages, they represent your public face to the world. So you want to make sure that it's presenting how you want the customer to see you. Service packs affect your system's capability to operate. Usually they're critical system updates. Security patches, same thing. It's different in the sense you want to use it for patching a security vulnerability, but nonetheless you want to make sure you're applying it when it becomes available and you know that it's not going to affect your system's uptime. Third-party software releases, upgrades to third-party software like Adobe products or Microsoft Office or something of that sort. You want to make sure that you have the most current version, but you need to take in consideration when you change, let's say, move from an older version of Office to a newer version of Office, that there's a cross-compatibility during the interim of that conversion. Test data and test scripts, you want to make sure that whatever you're using for testing accurately reflects your environment. Parameter files, you want to make sure that the parameters being used are realistic parameters. Scripts, stored procedures, and job control language. You want to make sure that your scripts and procedures are accurately written and work. You don't want to have the wrong commands in there that might affect the ability of completing the task that the script is intended for, or might have some negative consequences. Customized vendor code, customized code just for you is more vulnerable because it doesn't have as much exposure for the detection of errors and bugs and security vulnerabilities, and at the same time, it requires a degree of trust for the development of that code, and ensure that it's not something malicious against you or something malicious isn't hidden in there. Source code of any kind, you want to make sure that nobody is modifying source code and putting in dangerous code into it. So if you are working for a software development firm or a company, you want to make sure that your code is pure and nobody's injected malicious code into the source code. And then applications, you want to make sure the applications that you have work, and then when you update them or you change version numbers, that doesn't cause a significant impact to the capability of your users to be able to do their job. Types of changes, change, the addition, modification, or removal of anything that can be or have an effect on an IT system. A standard change is a pre-approved change that is low risk, relatively common, follows a procedure or a work instruction. And then emergency change is a change that must be introduced as soon as possible. So a normal change, you would go to a control board, you would have people from various stakeholders discuss and review the change, and if they agree to it, they would make the change. Standard change might be something where you're pre-authorized to do it. Like, let's say Adobe Flash is not that big a deal to your organization, so therefore when a new Adobe Flash update comes out, you're authorized to go ahead and push it out to everybody without it going to the change control board. And then emergency change would be a new patch comes out for a security vulnerability that is a hot topic or a hot push, actively being exploited, and be potentially catastrophic to your organization. You streamline the process of approving that change so it can get into effect and block an imminent risk. Separation of duties. I know we've touched on this earlier in the textbook. It's the business control practice of duties being assigned to individuals in such a way that no one individual can control all phases of the process or the processing and recording of a transaction. This is also called segregation of duties. So, for example, somebody who puts in a purchase request order cannot approve that purchase request. You need somebody else who approves the request, so no one person has monopolization over the entire process. This is important means by which errors and fraudulent or malicious acts can be discouraged or prevented. Separation of duties can be applied in many organizational scenarios because it establishes a basis for accountability and control. Proper separation of duties can safeguard enterprise assets and protect against risks. They should be documented, monitored, and enforced. So the steps to implementing segregation or separation of duties is to identify an indispensable function that is potentially subject to abuse. So let's say payroll. Divide the function into separate steps, each containing a small part of the power that enables the function to be abused. So, for example, maybe in your payroll department you have one person who enters in a number of hours. You have another person who is responsible for putting in compensation rates, and then maybe another person who's responsible for benefits packages or whatever. You don't have one person who does it all because it makes it possible for that person to abuse it by either upping their benefits or modifying their pay rates or things of that sort, and being able to cover it up because nobody else knows what they're doing. So some best practices when it comes to separation of duties. Separation of duties between development, testing, quality assurance, and production should be documented in written procedures and implemented by software or manual processes. You don't want the people who are writing the software to also be the ones doing the testing or quality assurance, because they have a vested stake in making sure that the product gets through. You want to have separate people testing it so that they are independent of the effort and time that was put into generating the product. Program developers and program testers activities should be conducted on test data only. They should be restricted from accessing live production data. So I worked previously for a company that produced software that worked with large databases, and they had a database that was full of bogus data that was used for all the testing. It was formatted and contained similar data, just not actual data. End users or computer operations personnel should not have direct access to program source code. This control helps lessen the opportunity of exploiting software weaknesses or introducing malicious code or codes that have not been properly tested into the production environment, either intentionally or unintentionally. Functions of creating, installing, and administrating software programs should be assigned to different individuals. For example, since software developers create and enhance programs, they should not be able to install it on the production system. Likewise, database administrators should not be program developers on database systems they administer. All accesses and privileges to the system, software, and data should be granted based on the principle of least privilege, which gives users no more privilege than necessary for them to perform their jobs. Access privileges should be reviewed regularly to ensure individuals who no longer require access have their accounts removed. Formal change management policy and procedures should be enforced throughout the enterprise. Any changes in the hardware and software components, including emergency changes that are implemented after the system has been placed into production, must go through the approved formal change management mechanism. Change management and configuration management use different terms for their various phases, but they all fit into four general phases defined under configuration management. There's configuration identification, which is the process of identifying which assets need to be managed and controlled. These assets could be software modules, test cases or scripts, tables or various values, servers, major subsystems, or entire systems. Configuration control is the process of controlling changes to the item that has been baselined. Configuration control ensures that only approved changes to a baseline are allowed to be implemented. Configuration status accounting consists of procedures for tracking and maintaining data relative to each configuration in the baseline. It is closely related to the configuration control. Status accounting involves gathering and maintaining information relative to each configuration item. Then there's configuration auditing, which is the process of verifying that the configuration items are built and maintained according to requirements, standards, or contractual agreements. It is similar to how audits in the financial world are used to ensure that generally accepted accounting practices and principles are adhered to, and that financial statements properly reflect the financial status of the enterprise. Configuration audits ensure that policies and procedures are being followed, that all configuration items are being properly maintained, and that existing documentation accurately reflects the status of the systems in the operation. Configuration auditing takes on two forms, functional and physical. A functional configuration audit verifies that the configuration item performs as defined by the documentation of the system requirements. A physical configuration audit confirms that all configuration items to be included in a release, install, change, or upgrade are usually included, and that no additional items are included. No more, no less. Change management requires some structure and discipline in order to be effective. Change management function is scalable from small to enterprise-level projects. It can be adapted to small enterprises by having the developer perform work only on her workstation and having the system administrator serve in the build master function. The build master is usually an independent person responsible for compiling and incorporating changed software into an executable image. Backout plans. One of the key elements of change plan is a comprehensive backup plan. I think I've mentioned this to you guys before about how I've had some previous updates that broke systems, and what helped us out was that I had a backup plan to get us back to normal should something go wrong with the update. If the course of a planned change activity in production or a problem occurs, to prevent going forward, it is essential to have a backup plan to restore the system to its previous operation condition. A common element in many operating system updates is the ability to go back to a previous version. The ultimate in backup plans is restoration of a complete backup of the system. The developer checks out source code from the Code Control Tool Archive to the development system. The developer modifies the code and conducts unit testing of the changed modules. The developer checks the modified code into the Code Control Tool Archive. The developer notifies the build master that changes are ready for a new build and testing in QA. The build master creates a build incorporating the modified code and compiles the code. The build master notifies the system administrator that the executable image is ready for testing and Q&A. The system administrator moves the executable to the test QA system. QA tests the new executables. If the tests are passed, test QA notifies the manager. If tests fail, the process starts over. Upon manager approval, the system administrator moves the executable to the production system. To oversee the change management process, most organizations established a change control board. In practice, a CCB not only facilitates adequate management oversight, but also facilitates better coordination between projects. The CCB convenes on a regular basis, usually weekly or monthly, can be convened on an emergency or as-needed basis as well. The CCB membership should consist of development project managers, network administrators, system administrators, test QA managers, information security manager, an operations center manager, and a help desk manager. Others can be added as necessary depending on the size and complexity of the organization. A system problem report is used to track changes through the CCB. The SPR documents changes or corrections to a system. It reflects who requested the change and why, what analysis must be done and by whom, and how the change was corrected or implemented. Most large enterprises cannot rely on a paper-based SPR process and instead use one of many software systems available to perform change management functions. While this example shows a paper-based SPR, it contains all the elements of change management. It describes the problem and who reports it. It outlines resolution of the problem, and it documents approval of the change. Another thing that's important is code integrity. One key benefit of adequate change management is the assurance of code consistency and integrity. Whenever a modified program is moved to production source code library, the executable version should also be moved to the production system. Automated change management systems greatly simplify this process and are therefore better controls for ensuring executable and source code integrity. The executable code is critical. A common hacking technique is to replace key system executable code with modified code that contains backdoors, allowing unauthorized access or functions to be performed. Executable code integrity can be verified using host-based intrusion detection systems. These systems create and maintain a database of size and content of executable modules. An important set of process models are the Capability Maturity Integration Series developed by the Carnegie Mellon University Software Engineering Institute. SEI has created 3 Capability Maturity Model integrations that replace the older Capability Maturity Model. Capability Maturity Model integration for acquisition, Capability Maturity Model integration for development, and Capability Maturity Model integration for services. The Capability Maturity Model integration dev is representative of the 3 models. One of the fundamental concepts of CCMI dev is configuration or change management, which provides organizations with the ability to improve their software and other processes by providing an evolutionary path from ad hoc processes to disciplined management processes. So in the capability maturity model integration, there are 5 maturity levels. Level 1 is initial. Processes that are generally ad hoc and chaotic. The organization does not provide a stable environment to support processes. Level 2 is managed. Processes are planned and executed in accordance with policy. The projects employ skilled people who have adequate resources to produce controlled outputs, involve relevant stakeholders, are monitored, controlled, and reviewed, and are evaluated for adherence to their process descriptions. Level 3, defined. Processes are well characterized and understood, and are described in standards, procedures, tools, and methods. These standard procedures are used to establish consistency across the organization. Level 4 is quantitatively managed. The organization establishes quantitative objectives for quality and process performance and uses them as criteria in managing projects. Quantitative objectives are based on the needs for customers, end users, organizations, and process implementators. Quality and process performance is understood in statistical terms and is managed throughout the life of the project. And then finally, level 5 is optimizing. At maturity level 5, an organization continually improves its processes based on the quantitative understanding of its business objectives and performance needs. The organization uses a quantitative approach to understand the variations inherent in the process and the cause of process outcomes. I'm your instructor, Peter Keurig for Nashville Community College. Thank you for watching.